So in a previous lecture, we talked about finding the equation of a parabola, which is a quadratic equation, given some information. The information we were given was very kind of parabola-centric, right? For example, we knew the location of the vertex and the focus, or the location of the vertex and the directrix, right? And those are very parabola geometric kind of concepts, and that was fine. But what if all we know are points? Right? What if I know the vertex and the coordinates of another point on the parabola? Well, I can't get to the focus or the directrix from that information. So our parabola analytic geometry methods aren't going to work in this situation. Turns out we can still answer the question, right? And that's what we're going to talk about in this lecture and the next one. So if we're thinking about just basing this on data values, what do we need to know to make this happen? Well, if you think about it for just a minute, two arbitrary points on the parabola aren't sufficient, right? Because, for example, if I have these 2 points here, right, well, this parabola goes through them, but so does this one, right? And never mind those two. If you don't believe that red one is a parabolic shape, just take the blue one, the first one I drew, and flip it over. Now you've got a wildly different parabola that also passes through those points. So there are two answers to this question, right? If one of the points you're given is the vertex, then you can get by with two. Right, the vertex and one other point is sufficient to answer this question. If none of the points you're given are the vertex, then the answer is going to be 3. You need a minimum of 3 points to uniquely determine a quadratic equation. All right, so in this lecture, we're going to talk about the vertex plus a point case. Then in the next lecture, we'll talk about the 3 arbitrary points case. And at this point, I'm really kind of taking this from the perspective of an algebra class more so than a pre-calc class. Because you remember when we talked about parabolas earlier, we talked about 2 different kinds. We talked about up-down parabolas and left-right parabolas, right? For our purposes here, we're going to take kind of more of an algebra approach, and we're only going to think about parabolas that are functions, that is up-down parabolas. All of the things that we do here apply just as well if you know that whatever situation you're working with is modeled by a left-right parabola. Just switch the x's and the y's. Okay, so an example here. I want to find the equation of the parabola whose vertex is at 3, 2, and that passes through the point 1, -2. Well, I'm going to assume that this is an up-down parabola. So and what I'm going to do is I'm going to write this in that vertex form. Right? So I'm going to rely a little bit on what we did when we were talking about parabolas. Right? I'm going to write y equals a x minus h squared plus k. Right, and if you think back to the previous lecture where we're talking about finding a formula for the vertex of a function, this is kind of for the vertex of a parabola. This is where we ended up when we completed the square. Right, we had a times x minus this h, which turned out to be the x coordinate of the vertex, plus, and we had a more complicated thing over there that was in terms of a's and b's and so on, but really it was just a number. And that number was the y coordinate of the vertex. So this is what's often called the vertex form. Okay, so This h and k, those are the coordinates of the vertex. So those are 3 and 2. All right, so let's drop those in here. Y equals a x minus 3 squared plus 2. And there we are. Awesome. That's like 2/3 done, and all we've done is a little substitution. We do, however, still have to find that a. Right? And finding that a is going to be just a matter of dropping those coordinates into the equation. Right? If I do that, I'm going to put -2 in here for y equals a 1 minus 3 squared plus 2. And now I'm just going to solve this for a. -2 equals, let's see, 1 minus 3 is -2. -2 squared is 4. So this is 4a plus 2. Move the 2 over. 4a equals -4. A is -1. And there you go. Right? I'm going to take this. I'm going to put it back into here. And if I do that, my equation becomes y equals -x minus 3 squared plus 2. And you could arguably leave it there. That's a reasonable answer. Your professor, your whatever software program maybe you're using in class may expect you to multiply this out, and okay, I mean, we can do that. This is -x minus 3 times x minus 3 plus 2. Be really careful of that negative sign. -x squared minus 6x plus 9. Now distribute it. -x squared plus 6x minus 9, still plus 2. And combine those two like terms. -x squared plus 6x minus 7. And that's it. All right, there's my equation. And you can do a little reality check here. It's not a perfect check, but you can substitute both of those pairs of points, 3, 2 and 1, -2 into there, and confirm that those 2 points are in fact, they satisfy that equation. So they are in fact on that equation's graph. Okay, so what else could we, again, if you want to do a little check here, if we do a quick sketch, the vertex is at 1, 2, 3, 2, and it goes through the point 1, -2, that's down here. The only way that can happen, again, because we're assuming up-down parabolas, is if it looks like this. That is a downward parabola. And yeah, my leading coefficient, my a term here, is negative, which is what we expect from this kind of equation. Okay, so again, we're just going to focus on the up-down case. If you wanted to do this for a left-right parabola instead, then all you would do is you would start with the equation x equals a y minus h squared plus k, and then you would go through the exact same process. You would put 3, 2 in here for the vertex, then you would put the other point in here and solve this for a, and then you'd have your left-right version of the equation. Okay, so that's one of our 2 cases, right? That's the special case where one of the points we know is the vertex, and it's not an unreasonable assumption. You may know what the maximum or minimum value of the situation where this data came from is. However, you might not. So in the next lecture, we're going to look at really the most general case where we just have 3 points, none of which are particularly special other than that we know they're on the graph of the function. And we're going to see how we can take that situation and find the equation of the parabola that passes through those points.